Here given that a matrix A equals to A B C 0 A D 0 0 A. So its characteristic polynomial equals to characteristic equation determinant of A minus x B C 0 A minus x D 0 0 A minus x equals to 0. So this is the characteristic equation. So this implies A minus x into A minus x the whole square minus 0. So this is equals to 0. This equals to A minus x the whole cube, that is A cube minus 3A square x plus 3AX square minus x cube. So we know by Cayley-Hamilton theorem every matrix satisfies its characteristic polynomial. So A cube I minus 3A square A plus 3A square minus A cube equals to 0. So from here we write A cube equals to A cube I minus 3A square A plus 3A square. So these are integer. So option A is correct answer. For option B, here given that QA equals to QA, QB, QC. Let us assume Q equals to x plus 1. So QA, that is A plus 1 0 0, B plus 1 A plus 1 0, C plus 1 D plus 1 and A plus 1. But from this QA equals to x plus 1, that is QA equals to A plus I. So A plus I not equals to this. So these are not equal. So B is our wrong answer. For option C, A to the power n equals to 0, that is A is nilpotent matrix. So characteristic polynomial of A equals to x cube equals to 0, and by Cayley-Hamilton theorem we can write A cube equals to 0. So option C is our correct answer. Option D says that A commutes with this matrix. Say that dash 0 A dash 0 0 0 A dash. So A equals to A B C 0 A D 0 0 A. This is commutes with this matrix. So this equals to A dash A, this is A dash B, and this is A dash C plus A C dash 0 A dash D 0 0 A dash. So now A multiply with this A B C 0 A D 0 0 A into A dash 0 C dash 0 A dash 0 0 0 A dash. So this equals to A dash A dash B A dash C plus A C dash 0 A dash D 0 0 A dash. So this and these are equal. So option D is our correct answer.